So I had number 6, and we are told that the triangle ABC has mutually tangent circular arcs centered at the 3 vertices. We also know that angle A is 45 degrees and angle B is also 45 degrees, and that AB is 18. So we know that this entire length right here is 18. And we're told that the intersection of the arcs centered at A and centered at B intersect at the midpoint of line AB. So we know that on this half we have 9, and on this half we have 9. So for these arcs, we know that the radius of each of them is 9. So that can continue down to here and to here because the radius is consistent on all sides. So because both of them have radius 9, we know that this arc is equal to this arc. On the other side, we have angle C, or arc C, centered at angle C, that we still have to figure out the radius for. So because this is a 45, 45, 90 triangle, we know that the sides are in a ratio of 1 to 1 to radical 2. So to get this right here, because we already know the hypotenuse, we need to do 18, which would be part of the radical 2, and divide it. So this right here would be the hypotenuse divided by radical 2. And because we already know that this radius right here is 9, we can do 18 divided by radical 2 minus 9. And that gives us the radius for C. So now we have to figure out the areas in order to leave us with this shaded portion right here. So for A and arc B, we can do area equals pi r squared, because that's a normal circle. But because it's 45 degrees, we know that 45 degrees is 1/8 of the total 360 degrees that a circle is. So you have to do area equals pi, and we know the r is 9 squared times the 1/8. And we get the area is equal to 31.8086. So both A and B have an area of 31.8086. And then we can also figure out the area of the arc C. So we have area equals pi r squared. And because C has an angle of 90, we know that 90 is 1/4 of 360 degrees. So then we know area equals pi, and our r is 18 over radical 2 minus 9 squared, and then you keep the times 1/4. And that gives us an area of 10.91499. And then we also need the area of the overall triangle. So for that, we know the area equals 1/2 base times height. We know that the base is going to be 18 divided by radical 2, which we figured out. And because this is the exact same, a radius of 9 and a radius of 18 over radical 2 minus 9, it's also going to have the length of 18 divided by radical 2, and we get the area of the triangle to be 81. So we have the area of the triangle, areas of A and B, and the areas of C. So then all we have to do is take the triangle area minus the sum of all the areas of the arcs. So we have 2 arcs that have an area of 31.8086, and we have one that is an area of 10.91499. So this is the sum of all the arcs, the area of the arcs, and this is the triangle area, and you subtract triangle minus all of the arcs to get what is left inside the triangle, not included in the arcs. And for our answer, we get 6.4678. So that is the area of the region left outside the arcs but still contained in the triangle.